Right, for question 3, we can see a sector on the diagram, and there's r for the radius and theta for the angle, and there's a little shaded part between the triangle and the curved part of the sector. The diagram shows a sector, center O, radius r, angle OAB is theta. They just told us that. It's given that the length of the arc is AB is 9.6, and the area of the sector, that's the whole sector, is 76.8. Find the area of the shaded region. Well, the area of the shaded region is the area of the sector minus the area of the triangle, but we can't find out the triangle until we find out the angle and the radius. So we have to use the information that we're given to try and work out what the radius is and what the angle is. So using our knowledge of sectors and radians, we would say that the arc length, which is r times theta, is equal to 9.6. And the area of the sector is a half r squared theta, and that equals 76.8. Okay, so we have two equations, two unknowns we can solve, but there's a really simple way of solving these two equations. If you notice in the second one, we can actually write that as r times r theta, and the only reason you would do that is because r theta is what we have in exactly the first equation. So we're going to substitute the r theta with 9.6. All right, so a quick rearranging. Well, let's explain what we're doing. We're going to take equation 1 and substitute it into equation 2. And we're doing it in the nicest way possible. All right, so let's rearrange at the same time. So because we're going to multiply by 9.6, we can take the 9.6 over to the other side and divide by 9.6. Of course, you don't have to do rearranging all at the same time. Do whatever you're not going to make a mistake with. We're multiplying the radius by half, so the 2 comes up and multiplies by on the top, which now gives me a radius of, you throw that into a calculator, and we will get 16. Great. So how do we find out theta? For theta, we take r, we substitute it back into one of the equations. The easiest one, of course, is equation number 1, and we will get r is equal to 9.6. Sorry, we'll get theta is equal to 9.6 divided by the radius, which is 16, and that gives us an angle of, oh, nice, 0.6. Okay, so now that we know the radius and we know the angle, we can work out the shaded area, which of course is the area of the sector minus the area of the triangle. So the area, let's write that. Well, we already know the area of the sector. They told us that, and the area of the sector is 76.8. And the area of the triangle is, we're going to use as a formula, half AB sine theta. But in this case, A and B are the radiuses. Both of them are the radius, and we work the radius out is 16. So it's going to be 16 times 16 times sine of the angle between them, and the angle between them is 0.6. Okay, so we've put that into a calculator, and we will get the shaded area, which is what we're trying to find. And that turns out to be 4.52576 on it goes. On the front of the exam paper, it says give your answers to 3 significant figures. So we're going to round that to 4.53 because it's 525. And should we use units? We should always give units where possible. The area is in centimeters, and so the lengths are in centimeters, so the area is in centimeters squared. And part A is done. Part B, find the perimeter of the shaded region. Well, we already know the arc length, and all we have to do is find the length of that side of the triangle, which is over there. So the perimeter is going to equal the triangle side, and then plus the arc length. All right, they already told us the arc length. We should spell that right. TH would be nicer. We know the arc length. The arc length is 9.6. And so we just have to find the side of the triangle. Right, to do that, we now, well, it's actually easy to find half the side of the triangle because the sector looks like this, right? There's the side of the triangle that we're trying to find, and there's the arc. And we're trying to find the perimeter of that little shaded area there. What we do know is with a chord, if you go to the center of a chord, it makes 90 degrees. So if we draw a line there, we've got a 90-degree triangle. Well, half the big triangle, the isosceles triangle with the radiuses, is going to make me, and of course the radius is 16, is going to make me a triangle, two equivalent triangles. The theta that we found was 0.6. If we halve 0.6, we're going to get 0.3. And so now it becomes quite trivial to find the length of that side of the triangle, the opposite side to the 0.3. And that is half the side that we're trying to find. So we could write this. 2 times that side is going to be 2 times, this side is going to be 16 sine 0.3. So that's 2 times 16 sine 0.3. If we just put that into a calculator, and we get 19.1, 3 significant figures. 19.1 is our perimeter, and let's stick with centimeters. We're done. The question. Well done.